Well, Bob here for the Old Iron Lever channel. We're continuing on our shop tune-up series on the South Bend lathe, where we're upgrading the drive side of the lathe, the motor and the spindle belt, all that kind of stuff. The first video was on the motor itself, and since we moved to a three-phase motor and only have single-phase power in the shop, we have to put a VFD in to drive the motor, and they're not terribly expensive in the size range that I have in the shop, so I tend to do that rather than a rotary converter. So this next little video will show me basically wrestling with sheet metal, and I bought a box, an enclosure for the VFD. And I wanted it to have a hole in the panel so that the VFD, the face of the VFD, protruded through the panel slightly, so I have access to all the controls and everything. The first bit of this, I'm building a base plate out of aluminum. The VFD from front to back is not thick enough that if I mounted it to the back of the box, it would stick out through the front. So I put this base plate to space it out about an inch. Basically drilling and tapping holes. The VFD is mounted by a couple of holes, screws onto the base plate, where there's some ears on the box of the VFD. The back of the base plate, I drilled and tapped for some flathead screws, and they to make them sit flush with the back of the cabinet, I dimpled the cabinet and countersunk the back of the plate so the screws can kind of set into a dimple in there. And then you'll see we'll have some other parts too, but that kind of gets an introduction to the video. Okay, got your handheld just to show you what happened for the wiring and everything. The 220 or 240 coming in from the line above the box there. Wires into here. That's the cable on the right there. The middle cable is the three-phase going out to the motor, and the left is the little control cable that basically just turns it on going forward or turns it on going backwards. And that's the old drum switch that's just been rewired to send that signal to the VFD. And then I added a little hole and a screen for ventilation, and another one up above here. I wired in the old drum switch to trigger the VFD. That is a lot quieter than it used to be. That's Stan Zakowski had that, I think it's CRC spray-on molly lube, and it really did quiet down the gear cover. Anyway, that's it for now. This next segment, we're going to take a look at the replacement of the canvas sort of composite belt that was on the lathe, and we're going to replace it with a poly V belt. And the reason for that is to give it more traction, or less likely to slip. And in order to do that, because of the way the lathe is built, you have to cut the belt and then get it installed and then splice it back together. And I've done this before. The first belt I had probably lasted 3 years or so, and the splice finally came apart. I probably could have re-glued it, but I thought I'd go ahead and redo it. I ran into some struggles with the new belt. The way I built the old one didn't work as well on the new one, so I had to kind of regroup a couple of times, but you'll see we did eventually get the belt on it, and it works well, and I'll show you all that. So, on with it. Okay, we're going to start a new project. Going to take this old composite belt, looks like it's leather canvas sort of thing, off of the South Bend 13 lathe, and we're going to replace it with a serpentine belt. These things have a lot more friction. They really don't need to have them the same length or width as the original belt. And this is the first time I've done one that hasn't been. Anyway, so first we're going to cut the belt as square as we can. Got a nice square belt here. Doesn't really matter that much because we're going to cut the ends off anyway. So what we're going to do is we're going to come up to something that's about the same length as the original. I've run into problems with measuring wrong, mismarking it, that kind of stuff. I'm going to actually fit it on the machine, but we're going to wind up with an overlap here, and we're going to have a 3-inch section in the middle where I've skived off everything on the back side on one end and the front side on the other, down to where these cords are here. Get it up close where you can see it. These cords right here. So we're going to skive the back off on one end of the belt and the ribbed end on the other. We'll overlap it, and we're going to use some two-part plastic glue, just this Loctite product here. So we'll move over to the lathe and we'll continue. Alright, well here we are at the lathe. We got the belt cut off. The reason we had to cut the belt, by the way, is this casting right here. You have to go around it to get the belt on. There's no way to get, you know, there's no way to slide the belt in from one end or the other. Even taking the lathe apart, you couldn't get to it. So, the belt, the lever that raises and lowers the drive pulley on the bottom is in the tension position. Okay, I got it clipped into place here. One of the things I'm going to do is mark one end of the belt. And I'll show you why I'm marking it this way in a little bit, but trust me, it's a good idea. So I'm going to take a couple of inches off the end here. And then we're going to go about 3 inches, which is going to be my splice distance. And this is approximate, it's not critical. Okay, so just for the sake of a starting point here, this is the piece we're going to skive off of the back. Now, I'm going to get this in position, and I'm going to pull it around and pull it up tight. Get it where you can see it a little better. Okay, so there's the piece we're going to skive off of the back, and then this piece will lay up on top of it. Move this out just a little bit. There we go. So the lever is in the tensile position, the running position. Now, I'm marking it here, but I'm actually going to skive the bottom half off of here. Pull this back out and we'll go back to the bench. Okay, let's kind of review here. When the belts splice together, this is the length we want to fit around the pulleys in the tensioned position. So as I marked before, this is going to be our skived area off of the top of the belt, and then this is going to be transferred to the bottom side here, and this is going to be the skived area for the bottom of the belt. It's just touching it there. It's just touching it there. That's pretty square right there, so go with that. And it's going to come down to a kind of touch off here. Well, I'm not sure if you saw the bozo move there, but I used this 1-inch cutter here, and I didn't think about the spiral flute. So when they started getting into the edge of the belt, it just acted like a screw and pulled everything loose. The last time I did this, I used this cutter here. You can't see it. I used this cutter here, and that worked fine because it didn't have the spiral flutes on it. So anyway, we'll get this thing set up and we'll try again. I think the problem that we've run into with the using the milling machine, even though I've done it a couple of times successfully, is that this belt may be actually thinner as well as narrower than before, and it's just too thin for the mill to be right tool to get in there and just barely take off something. So I'm going to just do it with the Dremel. It'll take me, a lot longer, but in the long run it'll probably be a lot faster. Now we're right on the top of the cord there, and I'm kind of wondering if I want to try and take this cord down half the thickness of the cord, or do I want to just take a couple of strips out and then do the matching strips coming from the other direction. Food for thought. If I don't do one or the other, the belt winds up too thick. Okay, we're ready to glue this thing up and see how well it works. First thing I've done, just to keep things from sticking where I don't want them to stick, is I took some beeswax and kind of waxed this piece of the pulley. Got a piece of wax paper, and there is the belt ready to go. 2 halves, so I'm going to put the activator on both halves to start with. Let it set for 1 minute, and then go with the glue next. Here we go. It's kind of hard to tell if you're putting this activator on or not, but once you get it flowing, you'll see it'll wet it for just a second, and then it kind of dries up again. Hold that. Okay, that's been a minute or a little bit over. So we're going to pull this up into place here, right here. And I'm going to put a bunch of glue on this. See, I didn't want to get that all over, but at least it's waxed. That. Give it a, it says give it 30 seconds, but what's it hurt to give it a minute, huh? Slide this over a little bit. See, it's still a little wet right there, so I'm going to clamp it. Like that. And we'll just let it sit there, and I'll probably have to scrape the clamp off of it, but that's okay. We'll come back after a while and see how it held. Okay, there's the belt. In the tense position, you can see there's a lot of slack there, so I don't have it real tight. So basically I just made it tight enough that it didn't slip, squeal when I was taking a test cut with it. And I have been able to, with the old canvas composite belt, able to take about a 50 thousandths cut, and that's with the old 1 horse motor, and things started slipping about then. We've got the 1.5 horse motor now. I've got this new belt in here, and again, it's not real tight. It's a narrower belt. I haven't done it this way before, and the splice is only like 1.25 inches long instead of 3 inches like I typically do. So there's a little bit of experimentation going on here. I guess, to be totally honest, the reason the splice is so short is I had a couple of mishaps and I had to cut the belt shorter. So that's all the belt I have left. So anyway, I'm going to take like a 75 cut on this with the normal feed rates I would normally use on a piece of unknownium steel, and we'll see what happens. So I imagine I can take more than 75, but we'll just try it at 75 to start with. A little chatter, but it's cranking. Handling it, no problem. I don't know if it'll take 100, but let's give it a try. I would say that's a success. So that kind of concludes this this part of the shop tune-up on the lathe. I've got some other things I want to do to the lathe. I want to get a handle on this Dolores tool post, and this compound is pretty loose, and it does contribute to a lot of lack of rigidity. So I'm going to do the Robin Renzetti fix here, which is to build a solid block under here that the tool post will sit on. And I believe this tool post has an index hole in the bottom of it, so I'll try to set it up so once it's in here, everything will be locked in. It'll be 90 degrees, and no matter how much of a cut I put on it, it'll be perfect. It'll stay put. So anyway, until the next time, happy trails. Well, thanks for watching again. As always, if you liked it, please give it a thumbs up. If you like the channel, how about subscribing? I love to have subscribers. We, by the way, we just passed 2,300 subscribers, and for a guy like me making videos and thinking about how many people are watching it, 2,300 is just amazing. I mean, it's not an Adam Booth where he's got like 250,000, but 2,300 people like my videos. That's very cool. Thank you. So anyway, till the next video, happy trails.